All right, hello and welcome. So today, we're not just going to be crunching numbers. Nope, we're actually going on a quest. Our mission? To track down these wild, kind of messy mathematical expressions and tame them to find their true, simplest form. You know, it's all about making math look clean and elegant.
So, let's kick off this quest with our first challenge, the square root of 72. I mean, it looks simple enough, right? But what is its actual simplest form? Let's think about that for a sec.
Okay, so your first instinct might be, well, 72, that's 9 times 8. And you'd be right. So you could totally write it as the square root of 9 times the square root of 8. And you know what? That's a great first step. Perfectly valid.
But what if someone else looks at it and says, nah, the answer is 6 times the square root of 2? Now that looks a whole lot cleaner, doesn't it?
Okay, so let's recap. We've got the square root of 72, we've got the square root of 9 times the square root of 8, and we have 6 root 2. 3 different looking expressions, but they all represent the exact same number. So our mission, right here, right now, is to figure out what simplest actually means and how we can get to that simplest form every single time without fail.
So, here's our game plan. We're going to dive into the 3 golden rules for simplifying radicals, and then we'll put it all together to see how to actually work with them.
All right, let's get into the rules of the game. To really conquer this quest, every single radical expression has to pass 3 tests. It's got to follow 3 specific rules to be officially called simplified. Think of it like a final checklist before you can spike the football and declare victory.
And here they are, the 3 golden rules. These are our guiding principles for this whole quest. Rule 1. You can't have any perfect square factors, like 4 or 9, still hiding inside the radical. Get them out. Rule 2. No fractions allowed inside the radical. Nope, not on our watch. And Rule 3. Absolutely no radicals in the denominator of a fraction. You master these 3 rules, you've basically mastered the entire quest. Simple as that.
Okay, let's jump into rule number 1. This is all about hunting down any of those sneaky perfect squares. You know, numbers like 4, 9, 16 that are still hiding inside our radical. And to do that, we need a special tool.
And here it is, the product property. This thing is awesome. All it says is that if you have the square root of 2 things multiplied together, you can just split it. It becomes the square root of the first thing times the square root of the second thing. This is a game changer because it lets us break down a big, scary radical into smaller, more manageable pieces.
So, let's put this tool to work on the square root of 108. Now you could look at 108 and see, oh, 4 is a factor, or 9 is a factor, and that works. But if you want to be super efficient, the trick is to find the biggest perfect square that goes into it. In this case, it's 36. So we rewrite it as the square root of 36 times 3. The square root of 36 is just 6, right? So that 6 gets to escape from the radical sign, leaving the poor little 3 behind. Boom, 6 root 3. So simple, so clean. Okay, rule 1 is down. We've successfully kicked out all those hidden perfect squares. High five. Now let's move on to our second golden rule. No fractions camping out inside the radical sign. Time to evict them.
And for this job, we've got another great tool, the quotient property. You can think of it as the product property's cousin. It works exactly how you'd think it would. The square root of a whole fraction is just the square root of the top divided by the square root of the bottom. It lets us split that fraction up and deal with each part separately.
And just look how slick this is. The square root of 81 over x squared, we just split it. It becomes the square root of 81 on top and the square root of x squared on the bottom. We know both of those. That's just 9 over x. And just like that, the fraction inside the radical is gone. Rule 2, check.
All right, we are at the final boss, the 3rd golden rule. And this one is a biggie. It's kind of like a rule of good manners in math. You never, ever leave a radical in the denominator of a fraction. It's considered, well, messy.
So how do we clean it up? The technique has this fancy name, rationalizing the denominator. But the idea behind it is so simple, it's brilliant. We're basically just going to multiply our fraction by the number 1, except it's going to be in a very, very clever disguise.
Think about it. How do you get rid of a square root? Well, you square it. So to turn the square root of 3n into a nice, rational number, we just need to multiply it by itself, by the square root of 3n. But of course, to keep the value of our fraction the same, whatever we do to the bottom, we have to do to the top. So we multiply top times bottom by the square root of 3n.
Okay, wait a second. I know what you're thinking.
hold on, we're multiplying the fraction by something new. Doesn't that totally change its value? And that is an excellent, excellent question.
And the answer is nope, not at all. Because what are we multiplying by? We're multiplying by the square root of 3n divided by the square root of 3n. Anything divided by itself is just 1. We're just multiplying by the number 1 in the most useful disguise ever. We're changing how the number looks, for sure, but we are not changing its value one bit.
Okay, that little trick is perfect when you've got a simple radical in the denominator. But what happens when you run into something a little scarier, like a denominator that's 2 minus the square root of 3? Yikes. If we just multiply by root 3, that's not going to fix it. We're still going to have a radical down there. For this, we need a new secret weapon.
And that secret weapon is called the conjugate. It sounds complicated, but it's super easy. The conjugate of something like a minus b is just a plus b. See? Same two parts, he just flipped the sign in the middle. And the reason this is so magical is what happens when you multiply an expression by its conjugate. So here's the play. We multiply the top and the bottom by the conjugate, which is 2 plus the square root of 3. Again, we're just multiplying by a fancy version of 1. Now, the numerator gets a little busier, that's true. But who cares? Look at the denominator. When you multiply it out, the middle terms with the radicals just poof, they cancel each other out. And the square root itself vanishes, leaving us with a beautiful, clean, rational number on the bottom. It's just fantastic.
Okay, we did it. We've mastered the 3 golden rules. So for our final challenge, let's see why this matters so much. Now that we have these skills, we can actually start doing things like adding and subtracting radicals.
Now here's the big idea. You can only add or subtract like radicals. That just means the number inside the radical has to be exactly the same. It's just like trying to add apples and oranges, right? You can't add 3 apples and 2 oranges and say you have 5 apple oranges. It doesn't work. So if you look at 10 root 5 plus the square root of 20, at first you'd say, nope, can't do it. Different radicals. But wait, this is where our quest pays off. We can simplify the square root of 20, right? That becomes 2 root 5. And suddenly, look, we have 10 root 5s and we're adding 2 more root 5s. Now they are like terms. We can totally combine them to get 12 root 5s. See, simplification was the key that unlocked the whole problem.
And that's a wrap. Quest complete. We've got our 3 golden rules down. No perfect factors left inside, no fractions inside, and absolutely no radicals in the denominator. That simple checklist is your ultimate guide to taming any wild expression you come across. So the only question I have for you is, now that you've got these tools in your toolkit, what other mathematical quests are you going to solve?